Hello everybody and welcome back. This week's update did take a bit longer than I had expected, and it was due to a few surprises along the way, and I'll talk a bit about those. But first of all, let's show what I've changed and what is working now that wasn't working before. First of all, the SD card is now working. And you can see when I start the small PC or the small home computer, it now has a small self-test that will open a SD card file, load it, print its contents, and close it and check that it's closed. It's all pretty simple, and it was designed to be pretty simple because it is just a test of the things that are happening, because the SD card is not connected to the main CPU but to the second one, and there is a sort of remote procedure call interface between the two of them. That was the cause of some of my despair of this week. More to that later. Now, if I remove the SD card, turn it back off, turn it back on again, the same test will fail horribly, just to show that it's a real test. So let's turn it back off, reinsert the card, and the little text is back. It says 10, print, I am a program from SD. Oh yes I am, come look and see. Now, when I started out with all of this, I started out by buying this keyboard, and that was probably the biggest problem that I had this week. It was this keyboard, because this keyboard is different from any other keyboard that I've had before, and it took me a while to figure out what's wrong with it. And in fact, it's a new keyboard. It is a let's put this here. It is a Perix mini keyboard, model yada yada 409. And if you come across this keyboard, don't buy it. It's not made for anything that is supposed to work. It's just a real curious piece of garbage. It's curious because it's a keyboard that was never designed to be a PS2 keyboard, because it's a USB PS2 switchover keyboard, but the switchover code, as far as I can tell, is broken, because it doesn't recognize the reset command sent to the keyboard, but instead comes to life when it gets the command to set the set key, break key, make key, break key, and typematic mode, which along the initialization is a lot further down. And in fact, I could put this to 3 different PCs and it wouldn't work. And it only worked on a very old laptop that was just sending the initialization but never expecting a return. So that was the thing that really irked me this week. It took like 4 days out of my development so I could just get this to work. And getting it to work was really simple. You just have to send a command first that would usually come later in the chain of commands to initialize the keyboard. And after that it worked perfectly. But let's leave it out. It didn't really make things easy. The second thing that I did was I changed the communication protocol between all the parts here. Before, I was using something called a TLV protocol, which stands for tag, length, and value. So you've got a field that is called the tag, which usually says it's something I want to get a value from the other controller, and it then tells it how long this datagram is going to be, and in the end you've got the value. To make sure that this doesn't actually get corrupted, I embedded this TLV in another packet which had a start and a checksum. And that was fine. The only problem was when something went wrong in here, it was really hard to find out how to synchronize again. So I would have to wait a grace period and just basically empty out all the serial buffers. That was okay, but it didn't work always, and especially when having commands sent back to back. Now, open a file, get the file status, get me the file contents, and it was happening really fast. It could get out of sync, and suddenly it would start producing very unusual results. So I went a step further, and I took the TLV structure together with the checksum, deleted the start, and put all of this into a COBS encoded packet. Now what COBS does is basically it gives you control of one character that you could use to synchronize your transmissions on, and that is the binary 0. So if the TLV and the checksum gets passed through COBS, you will get a packet that is exactly 1 byte longer, but it will no longer contain the 0. So my new packet would be a COBS encoded packet containing the TLV plus a 0 at the end. And that makes it a lot easier to synchronize the whole state machine again when you're done sending, or when you run into a problem, because you just have to find the next 0, or if you get a 0 too early, you can bail out and tell it your packet was not okay. And that made things a lot easier for me, and it's improved the code quite a bit, albeit I have to add 1 byte per packet, which I think I can live with. Then I had some timing issues regarding file transmissions, because the main teensy and the secondary teensy are communicating at 500,000 kilobaud, which was pretty fast. And it turns out that some of the grace periods that I was using were just too large for that. So I could have a input buffer overrun while I was still waiting for the second packet. And after I figured that one out, everything became really smooth running again. And the changes that I had to do for accessing the files and everything, they were really simple. And the whole code is now pretty simple too. It's once again really easy to read. I haven't done a lot of optimization, and I'm not going to do it for quite some time, so it just stays easy to read, because if you start optimizing stuff, usually this ease of use goes away a little bit. What I haven't done yet, and that's the reason why I can't really show loading and saving from BASIC yet, I haven't provided any encapsulation to all these commands opening the file. So opening a file still means sending a command to the other teensy, open the file, then send a command, tell me if it worked, send a command to get the first, 10 bytes of that file, and so on and so forth. And some of that handling still has to be improved or added. And then in the end, it will get wrapper functions, which will just be called open file, read file, close file, and so on. And I will be working on that, and this is to come. The other thing that I fixed was when I had this COBS encapsulation and I had the packet protocol, I could optimize the code. So, for example, when I'm playing a song, where the song is sent from main teensy to secondary teensy, and I was to input large chunks of data through the keyboard, I would have short dropouts in the communication. Or if I was to use the debug interface and send a large string to the main teensy, which it would have to put in its keyboard buffer, I could run into a problem. And after having the COBS encoding, I had frame borders that I could sync to, so I could basically interlace the communication between the two parts here, so I can enter stuff while it's doing something else, which is pretty good for multitasking. So you can load a file while you're still playing music. You can have graphic animations while you're loading files, stuff like that. I didn't get to initializing the ESP, and I really wanted to have that working, but this will take a bit more time because it appears that the ESP here isn't working correctly. And I also fried one Arduino because I didn't realize that when the Arduino is powered, another USB should not be touching the power regulator, because that has 3.3 volts on the backside of it, and that isn't so good for the Arduino. It didn't enjoy that at all. And it's got a fuse, but that fuse is now gone. So it's still working, but I can't use it to power the whole board. Too bad for that. So basically that was it. That was what I was doing this week, and things are still in flow. I have somebody else who's got one of these boards now, and I have another person who's rigged up a communication bridge between two teensies, and he's helping me test the serial communication, and he's going to be getting a board soon. And it's slowly moving forward, and I'm still pretty confident that this board is okay. It doesn't have any bugs on it. And so I think it's still smooth going. What I really like is that most of the code that I wrote is really straightforward. So if you were to say, I don't want to use BASIC, I want to use this as some sort of virtualization platform, you can still do that. The serial communication is not impaired by that, and serial communication does not make your code slower. Also, I still have the use of the whole second sound circuit on the main teensy, which could make for some pretty interesting demos, because you would basically have two SIDs that you could use in unison. Things like that. Also, I've done a few timings, so like writing a whole set of registers on the SID takes about 1.8 milliseconds, which is good enough because you're usually updating them at about 20 milliseconds. All of that sounds pretty straightforward. And also what I did was when I update the files that go to the Arduinos, everything is now done in packets instead of single bytes, which makes it a lot more efficient. So basically that was it for my week, and that was what I've been doing so far. And yeah, I just wanted to report back, wanted to show you that things are going great. Big thanks to David Watts for mentioning me on his channel. I really appreciate it. And for all my new viewers, welcome. I hope you like it here. I don't always do boards or electronics. I do a lot of machines, but since my 3D printers are kind of done for now, I wanted to do something else. I can't always do CNC and 3D printers and stuff like that, but I'm gonna come back to that. In fact, I'm already thinking about using this as a pretty nifty CNC controller, because I basically have everything I need back on the parallel port back here, and I've got some nice I/O, I've got a lot of processing power, so it would be really interesting to use this for that reason. yeah, so basically that's about it for this week. It took a bit longer than I had expected, and well, I didn't get as far as I was hoping to, but still, I'm really happy with the results so far, and I'm just going to keep going. So thank you very much for watching, and bye bye.